All right, welcome to section 2.1, conditional statements. Let's see how many of you actually watched this video. See if you can give me the answer to this riddle when we have class again. What is the beginning of eternity, the end of time and space, the beginning of every end, and the end of every race? Think about it. All right, warm-up quiz. Hopefully you already answered these questions. Let's go over the answers. Vertical angles are congruent. Linear pair contains two supplementary angles. Both of those are true. For a true statement to be true, it must always be true under all circumstances. Number 3 is an and statement. For an and statement to be true, both parts have to be true. So a right angle is 90, that is true, but an acute angle is not more than 90, less than 180. That's obtuse. So that makes the entire statement false. For an or statement in number 4, either or has to be true. So perpendicular lines intersect at 90 or parallel lines intersect at 90. Since the first part is true, that is enough to make the entire statement true. 3 and 4 are called compound statements when they're combined with and or. Number 5, an angle bisector does not split a segment. Here in 5 and 6, we're looking at that word not, okay? Just seeing if it hopefully doesn't confuse you. In number 6, a midpoint is not an endpoint is true. I put most times because sometimes kids argue, well, the midpoint of one segment could be the endpoint of another segment. But what that question is actually asking is the midpoint of a segment not the endpoint of that exact segment? Alrighty. Venn diagram, how many people like football and swimming? That's going to be the part in the middle, 16. Football and not swimming is going to be 25, just the left side. And football or swimming means you add up all 3 numbers. All right. Next, vocabulary. A statement is any sentence that is either true or false. Okay. A compound statement, as I said, is 2 or more sentences joined together. A conditional statement, which we're going to be the main focus of, is a statement that's written in if-then form. For example, if it is popcorn chicken day, then I will race to lunch. In if-then form, the hypothesis, the second part, usually depends upon, the conclusion, the second part, usually depends upon the first part happening. So the hypothesis is the first part following the if, or represented with the variable p, and the conclusion is the second part following the then, represented with the variable q. So if it's popcorn chicken day is my hypothesis, then I will race to lunch is my conclusion. The converse is a conditional statement with the hypothesis and conclusion switched. If I'm racing to lunch, then it is popcorn chicken day. Does not necessarily mean the same thing. Take, for instance, the example, if an angle is 62 degrees, then it is acute. If I switch that around, the converse would be if an angle is acute, then it is 62 degrees. Doesn't necessarily have to be true. Inverse is when we put nots. If an angle is not 62 degrees, then it is not acute. And contrapositive is when we put nots and flip the order. If an angle is not acute, then it is not 62 degrees. Pause the video if you need to write down any of these definitions. A conditional statement is always written in this if-then format, but it doesn't have to be exactly like that. For example, we could not say the then part and it still have a conditional where the second part is a condition of the first part happening. Here are just a few more examples. All right. Writing conditional statements is typically if-then form. If it's not an if-then form for you, take the subject and put it in the hypothesis. For example, our first true-false question, vertical angles are congruent, can say if 2 angles are vertical, then they are congruent. Seals swim. If an animal is a seal, then it's going to swim. All right. Also, we could say implies. The first part of the hypothesis is implying the second part. Vertical angles implies that they are congruent. They can be true or false, okay? If the conclusion happens every time the hypothesis happens, then it's going to be true. But if the conclusion does not happen, even if the hypothesis does, then we say the statement is false. A counterexample is what we would use to prove a statement like that false. For example, here, if you live in Virginia and maybe you live somewhere else like Glen Allen, then you don't necessarily live in Richmond, so that would make that statement false. For us, we could say if you live in Pennsylvania, then you live in Millersville. That's false because you could live anywhere else in the Penn Manor School District. All right, symbolic logic, okay. Here's our symbols. We're going to use P for hypothesis, Q for conclusion. We also will use a little arrow to indicate P is implying Q. Okay, there's your arrow. And there's our if-then statement. If a number is prime, then it has exactly 2 divisors. The little tilde is also used to represent the word not. If we put the tilde in front of a P, then we are going to negate the conclusion. So we would say the angle is not obtuse. Okay. Also, negating a statement that already has a not in it would then, of course, make it positive. All right, and this arrow is used to represent the word and. Okay, as we talked about earlier, compound statements can have the word and in them. And this arrow is used to represent the word or. We are not going to go deep into logic, okay? If you take a logic class in college, good luck with that. All right, and then that is used to represent therefore. It implies that the conclusion is coming, the three little dots. All right, here are our three forms. We're going to look closer at these guys. We have the converse is where you switch them, inverse is where you negate them, and the contrapositive, which is of course the longest word, is where you do both, okay? So you negate and flip. Now, the thing that we want to know is that contrapositives are always going to be logically equivalent to the original statement. Let's go back to my popcorn chicken. Let's say that I raced to lunch on both popcorn chicken days and Italian cheese pizza days. So when I say the statement, if it's popcorn chicken day, then I will race to lunch, that's a true statement. If I flip it around, if it is not popcorn chicken, or I'm sorry, if I'm not racing to lunch, then it's not popcorn chicken day. That would still be true. But now if I would do the inverse, if it is not popcorn chicken day, then I am not racing to lunch, wouldn't necessarily be true because I also race to lunch on pizza days as well. And there are our examples, okay? So if the first conditional is true, the contrapositive is true. If the original conditional is false, the contrapositive is false. Biconditional, we want to add this to our notes somewhere. When a conditional statement and its converse are both true, the statement may be combined. This is usually used for definitions, and we can say if and only if instead of the if-then format. For example, the definition of a right angle is 90 degrees. So we could then say an angle is right if and only if it measures 90. Think about another definition, maybe the definition for perpendicular lines. Lines are perpendicular if and only if they intersect at a 90-degree angle. Okay, we can use that for any definition. All right, here are the answers to our examples. This video is getting long, so I'm going to go pretty quick here. Pause it if you need to. Angle ABC is right is the hypotenuse. Conclusion, ABC is 90. Two angles are supplementary is the hypothesis. Conclusion, they add up to 180. If-then form. If right XY is an angle bisector, it splits an angle into two congruent parts. If MN and PQ intersect, they are perpendicular. Could be another way you say that. Find the truth value simply means are they true or false? Are they true or false? False, true, false, false. Okay, and if the only one that I think you might have a little bit of questions on that last one, if two angles are complementary, then they equal 35 and 40 and 55. False, because they could be 45 and 45 and still be complementary, or they could be 30 and 60. All right. The others I think are pretty good. Find the converse, inverse, and contrapositive. I'll leave these up on the screen for a minute here. Converse, remember, we're just flipping the order. Make sure when you do flip the order, though, you leave the if and the then statement where they are. Don't flip those. You just flip the hypothesis and the conclusion. Inverse, we're putting in nots there. You might have to change your statement around to make it sound right. All right, you can put doesn't in there and isn't instead of putting the words not in if you want. And the contrapositive, we're flipping the order and negating it. Remember, the contrapositive is logically equivalent to the original conditional. The converse and inverse are also going to be logically equivalent to each other. All right, here's our answer. Whoops, is there a typo there? That should be our answer to 4B. Nope, that looks good. And then we'll be doing some bookwork, hopefully as a Soccer Tip quiz in class.